What do you see when you look at the ocean? Summer fun? Waves? Just a big body of water? Well, those are all right, but how many of you see the reason we're all here? How exactly did we get from fish to people? The first character in the evolution from sea to land was the hagfish. Truly ugly little goblins. These guys have no jaws, paired fins, or scales. And the only bone in their body is the skull to protect their cranium, which holds their brain. Fish have a very interesting way of breeding. The female lays the eggs in just a random location and then wait for the male to ejaculate on them, thus fertilizing them. The next character were the lampreys. The lampreys were still jawless and had no pair of fins, but their mouths were round and full of teeth, so they could latch on to prey and suck blood, like a leech. They latch on to other animals, which made it easier for them for transportation. The next step were the cartilaginous fish. Instead of bones, they had cartilage, which made them lighter and better for hunting. What also made them very good for hunting was that they had paired fins for steering and a streamlined fusiform shape like a football for speed. Cartilaginous fish then evolved into ray-finned fish. Ray-finned fish skeletons were made of bones instead of cartilage. They got their bones back because it was more durable. What's special about these guys is that they have web-bone fins, which, spoiler alert, later evolved into toes and feet for reptiles. The Tiktaalik, the fishapod. Who were they, and what importance do they have in the long run? Well, they were the literal step between fish and amphibians. Their arms are cool, but what do they really contribute? Their arms and jointed hands led to development of land creatures. Their arms also led to development of Isologous, who were the step between fish and amphibians. Even though they aren't still around today, the Tiktaalik played a big part in evolution. How the Tiktaalik and the rayfin differ? The Tiktaalik had 4 powerful arms instead of 2. The Tiktaalik's adaptations led to their descendants to travel on land. They were walking fish. They had gills and scales like fish, yet they had arms for pushing up. The reason they pushed up was that the Tiktaalik lived in murky waters, and the only way to see was to lift their head out of the water, which their eyes were on top. A close modern-day equivalent are the catfish. The catfish can walk in muddy waters for miles, as long as it's just damp enough. The next step, the amphibians. Amphibians were the next step in evolution, and a very important step, in fact. They were the primary stepping stone from water animals to land animals. Amphibians were the first animals that lived in both water and land. They were adapted with strong arms for both swimming and walking. They had webbed feet to help them swim, but they are flexible enough to walk on land. Their eggs are still a lot like fishes. They're sort of jelly-like, and they lay them in water so they don't dry out. The difference being with a softer shell. They also developed a unique way of mating. Instead of the spray and hope, they created something called amplexus. Amplexus is where the male frog mounts the female frog, so they have a higher chance of mixing the sperm and egg. Another way they differ from the fish is the heart. While fishes have 2 chambers in their hearts, 1 atrium and 1 ventricle, the amphibians have 3, 2 atriums and 1 ventricle. The 2-chamber hearts were not that efficient, because they often mixed the oxygenated blood with the deoxygenated blood, which led to the fish having to breathe a lot more. With the extra atrium, they can pump more blood and don't have to be as efficient because more blood is coming in. As the amphibian land invasion was going on, a certain species developed that would be the predecessor to one of the most interesting amphibians to walk the earth and swim the sea. The Odontoceti, a very early ancestor turtle, they were theorized to live in shallow waters near shores. They also had a almost shell-like thing with bones, but with skin covering it. The final leap from sea to land was the reptile. They started as amphibians and developed to live completely out of water. Their legs evolved from swimming-based design to a design that allowed for greater strength when moving on land. For example, their legs could now bow out. Also, how they differ from amphibians is in the heart. The reptiles make the three-chambered heart even more efficient by adding a septum in the middle of the ventricle. This addition helps sort out oxygenated blood from deoxygenated blood. The septum is not large enough to separate the ventricle completely in two, so is given the name 3.5-chambered heart, which are known as amniotic eggs. The amniotic egg is where the fetus is stored in the soft shell with the yolk sac for nutrients and the protective fluid and an allantosis, a sac where the fetus disposes of its waste. This was the first evolution of the egg we know today. It's a bird, it's a plane, no, it's an Archaeopteryx. Yeah, what? What is the Archaeopteryx, you may ask? Well, it has been theorized to be the link between reptiles and birds. Even though they were reptiles, they had traits that are associated with birds, such as wings, feathers, and beaks. Under their fluffy exterior, birds are a lot like reptiles. In fact, birds are heavily modified reptiles, modified enough to become their own species. For example, their feathers are made of the same material which scales are, which is keratin, a protein substance, which means feathers could have been modified scales that developed to help with flight. The four-chambered heart had 2 atriums and 2 ventricles, which allowed for the best blood separation. They also had the fancy lungs, air sacs, which made them lighter and hold in breath for 2 breaths, so they could get more oxygen out of the same air. Yet reptiles also took another route, the one of the Morgancondan. The Morgancondan variation were very different from birds. For example, some of their jaw bones migrated to their ears, creating a smaller jaw, and larger ear, which means more ear bones. Also, like birds, their scales became modified, but instead of for flight, they were used for warmth. This was called hair. That's right, the Morgancondan was the intermediate step from reptiles to mammals. Mammals had 3 steps in evolution. First were the monoterms. They laid eggs and also had no nipples, which were very distinct traits of mammals, which showed the connection between reptiles and mammals. An example of this is the platypus. The marsupial was the next step. They had babies early, but instead of being in a womb, they were in their pouch and they got nutrients from the nipples. An example are the kangaroos. The last group were the placentals. They had in utero development with placenta that gave the fetus protection and nutrients. The mammals also have a 4-chambered heart, like the bird, but they also have something incredible, a mammary gland which produces milk to help the newborns get nutrients. What comes up must come down, and so is the case with sea to land creatures. With all these species evolving out of the water, there was more and more room in the water to live and less on land. So some of the animals decided to get out of there and go back into the water. They developed blowholes so they could breathe through the top of the water, because as mammals they still had to breathe air, so the blowhole allowed them to put their heads above the surface and breathe. Example are dolphins, whales, and narwhals. Also, they had vestigial hips and femur bones floating somewhere in their hips, which is proof that they once lived on land because they used to be bones that were meant for walking. Also, some of the marine mammals had fur and claws, such as the sea otter and seal, which connects them to mammals. So there you have it, folks. From fish to amphibian to reptile to mammal to fish mammal. I jest really. The journey from sea to land and back again is truly an interesting one and a feat of wonders of evolution. How we went from something that was no more complicated than a slime ball to an animal that can run up to 80 miles per hour or fly so high in the sky. Thank you for watching.